All right, welcome everybody to another awesome video. Today is going to be all about the metric system, which is an awesome way to measure things much better than what we do here in the United States. So the metric system's uses, first of all, it's a standard system measurement used and preferred by most scientists, if not all scientists. And it's referred to as the International System of Units. So that's why sometimes you'll see it abbreviated as SI units, which seems backwards, but it's because it's French. Don't worry about it. Note that the metric is not the standard system here in the U.S. We use something called the English system, which is funny because even England doesn't use it.
What are some of the units in the English system that we always hear?
You've got inches, you've got pounds, you've got feet, you've got cups, you've got ounces.
We're not going to use those in class.
Nope.
No.
So no more inches or pounds, please.
So here's why scientists prefer metric. First of all, the English system doesn't make any sense. You try to convert everything, and like there's 2 cups in a pint, and 2 pints in a quart, and 4 quarts. You know, it's like there's all these different, or there's 5,280 feet in a mile.
You basically have to memorize everything.
Yeah, you have to memorize all sorts of stuff. And the thing is, too, it is outdated because it used to be based off of like body parts of
actual
the king.
feet.
Actual feet,
Hands.
or like there was some standard for what an acre was based on something in the kingdom, but it's all outdated stuff. It's like it has no cultural relevance right now.
Should have gone away a while ago.
Now, more importantly,
Like the dodo.
and I kind of referred to this already, but it's way easier to convert metric because all you got to remember is 10.
10.
Because everything is either 10 more, or excuse me, times 10 more, or divided by 10.
That's it.
Okay, and you'll get this in a second. And then finally, most of the world uses the metric system. So when you're a scientist and you need to communicate your results worldwide, it only makes sense that you use the system that 90% of the world uses. And even, I mean, I've worked in labs. Mr. Black, you've worked in labs. Mr. Harkins, you've worked in labs. You actually have some real science experience here talking to you. And I never saw the English system of measurement used.
Nope, not at
in
all.
Sort of lab activity.
Not at all.
Except for when we talked about how many miles we drove that day.
Yeah, that's about it.
We were reporting mileage to get reimbursed. But anyway,
Well,
that's irrelevant.
We do use a little bit here in the U.S. If you look at like cans of Coke, it says how many milliliters, or you buy a 2-liter.
Yeah, but that's
just, we're
commercial
really,
stuff. That's
we're just
size.
goofy.
So anyway,
All right, let's talk about this stuff. Now, we talked about the metric system being based off of the unit 10. So if you hear us talk about like, hey, it's base 10, this is what we mean. And to break it down a little bit more, when we say base 10, what we're talking about is it's basically 10 units for each step up or down the scale from our base unit. So let's say our base unit is either meters, liters, grams, joules, seconds. There's a whole bunch of different units we can use, but the ones I just listed are the main ones we're going to use. So give me a click here and let's go up a step. If we go up 1 step, we're basically taking our base unit and multiplying it by 10, which means if we're taking a base unit of meters, if you take 10 meters together, because 10 times 1, that is 1 decameter. And you can see the prefix there, deca. And when we say prefix, remember it's pre means before. So all you do is take your base unit and stick that prefix on the front. So a meter becomes decameter, and that means that there are 10 meters in that decameter. If you give me another click. Now if we take that base unit and multiply by 100, we have what we would call a hectometer, and I'm just going to use meters to keep this nice and simple. So what that hectometer says is we have 100 meters in 1 hectometer. Now if we go all the way to the top of what we're going to use, we have a kilometer, which is 1,000 times a meter. If you look at that meter stick that we've got, that we've used in class, you take 1,000 of those, lay them out end to end, that is 1 kilometer. Now the scale goes on up beyond kilo. For our purposes here, we're going to stop at kilo right now and just work at these guys. So if you look at deca, it's times 10, hectos times 100, and kilo is 1,000 times your base unit. But now we can go the opposite direction. If we're getting smaller, we're going to go on, still using meters, we're going to use decimeters. And what decimeters means is you can see the little fraction we have down there. It's 1 divided by 10. So if you take a meter and you divide it into 10 little pieces, each of those little equal-sized pieces is a decimeter. So that means that there's 10 decimeters in 1 meter. Let's hop down there. The next one is centimeter, which means 1/100th. Do you guys know where centi comes from? Where else do we use the word centi?
cents.
Cents, very nice. Have you guys ever heard, how about another one?
Smart.
Years?
Century.
Century. Century has how many years?
Nailed it. 100.
100. How many cents are in a dollar?
100.
There you go. Fast math. Very nice. Yeah, so that's where it comes from. You're going to see this common prefix. Centi says you're going to take that meter, chop it into 100 pieces. You're going to get a centimeter about that big. And there's going to be 100 of them on that meter stick. Let's go down to the end here. You're going to see milli for millimeter. They're the little bitty guys. That means you take that meter and you chop it into 1,000 pieces. Or that gram and chop it into 1,000 pieces. Or that liter or that second or whatever your unit happens to be. And you're going to chop those into 1,000 pieces. All right.
Yeah, sorry, I skipped ahead there.
That's okay, I'm good.
Anyway, now any of these prefixes can be tacked on to any of what we call the base units.
Yep.
Now what I mean by that, Mr. Harkins just used meters as an example. Now anything where you're measuring length, you measure that in meters.
Yep.
But you could also do millimeters, centimeters,
Decimeters.
decimeters,
Any of
decameters,
them.
hectometers, kilometers.
Yep.
And you
Kinda
can
change the
convert
pronunciation.
between them, right? You don't get
Yep.
stuck in meters. If you have a meter measurement, you can move up and down from that, right?
Well, like when you're driving a long way in Canada or something, they don't measure your distance in meters; they measure it in kilometers.
Yeah.
You know, so you can but you could also convert that to meters very easily.
Yeah. Or millimeters, you want to be crazy,
Right.
you can convert it down to those little guys.
Or even if you've ever heard of a 5K before, running a 5K, K stands for 1,000. People use interchangeably. They'll say, "Hey, I ran 5,000 meters," or "I ran 5 kilometers."
Huh.
We'll do more of those
Interesting.
conversions in class, I think.
Yeah, and we'll show you some in a second here too.
So mass, what's mass measured in?
Grams.
Yeah.
Very good. How about volume?
Volume is liters. Think of a 2-liter soda for that one.
So volume, for those that are confused, volume is a measurement of how much space something takes up.
Yeah.
So when you say have a 2-liter bottle of Pepsi or something, Pepsi did not pay me for this endorsement, that means you have 2 liters worth of space that Pepsi's taking up. Then finally, energy. This is an interesting one.
Yeah.
Energy is measured in something called joules.
Not lightning bolts.
So
Or Zeus's.
anyway, so what we're going to do, we have 3 sample problems. They're actually on the bottom of your note sheet, and each of us is going to walk you through one of those. All right, so for this first problem, we're going to go from centimeters to millimeters. Now, that C stands for centi, and that lowercase m stands for milli. Now, look where they are in relation to each other, okay? To go from centimeters to millimeters, or even from centigrams to milligrams, centi anything to milli anything, you go 1 space to the right, okay? So that's all you do with your decimal place. I'm going to draw this really large here. All you do is you take your decimal place, you move it once to the right. So you got 11, and there's a decimal place after it. So you have 11 millimeters.
Okay, guys, so let's try another one. This time we've got 114 decaliters. So this DK right here is this DK up here, deca. So it's just to the left of your base unit. That's where we're going to start. Now we're going to end up at kilo all the way over on the left. That's what this big K means there. The first thing we got to figure out is where the decimal's at, as usual. So 114, the decimal is right after it, because if the number doesn't show the decimal, it's all the way to the right. And what we need to do is go back up to our scale up here at the top, and we're going to take a look. We're going to go from deca to kilo, so we're going to make 1 hop, 2 hops, and end up over at kilo there. So the same thing's got to happen with our decimal. We're going to go there to there. So now we made a hop from 114 decaliters is actually 1.14 kiloliters. Simple as that.
All right, so this final problem, we're going to go from decagrams to milligrams. So if you look, the DK stands for deca, that's all the way over here. And milligrams are all the way over here. So let's take a look. We got to go 1, 2, 3, 4 spots to the right. Okay, so let's take that number. Now we need to go 4 spots to the right. So here's 1. Okay, now I've ran out of space. So when I move 1 more over, remember this is the same thing as multiplying by 10. So you add a 0. So that was 2, 3, 4. And then that decimal point goes after that. So 1.5 decagrams equals 15,000 milligrams. All right, thanks for watching. Have a good day.